Okay, and I have started recording, I believe. All right, so recording is started. All right, welcome Samuel. Welcome Ralichuku, both from Nigeria. You're welcome, you're welcome. It's great to have you here. Let's see, other people, you put in the chat a greeting. Welcome, you're welcome. Welcome, Jimmy from Zambia. It's good to have you here. UNZ Robotics. Very nice. Very nice. You're welcome. It's good to have you here. We would, as usual, we try to maybe give a few minutes for other people to settle in. So let's give maybe maybe about five more minutes for a few other people to join in. But we're already recording, so that is good. In case other people cannot join today, they can get access to the recording. But let's just give a few more minutes and then we will start off.
Donc, nous allons encore attendre quelques minutes avant de commencer la session pour laisser le temps à plus de participants de joindre le meeting.
If you're just coming or if you just got on the call, welcome. Please use the chat to send a greeting with your name, what team you are representing, and what country you are from. All right, so we can know you are here and keep track of that. Thank you.
Si vous venez juste de rentrer dans le chat, veuillez envoyer un message en vous présentant le nom de votre équipe, le nom de votre nom et le nom de votre pays. Merci.
All right, all right. All right, so maybe we can actually kick off. People can join us as they go along. All right, so again, welcome everyone. Thank you for being here. This is our second workshop, our second technical workshop for PARC 2024.
Donc, nous allons commencer la session. Donc, c'est notre deuxième workshop pour la compétition PARC 2024.
All right, let me put this in slideshow mode and move on. All right, so the first thing I want us to do before we move into the workshop is to have everyone here who hasn't filled out the participant survey form to do so. All right, so Andrea is going to put the link on the screen here to the chat. And if you haven't filled out this form, it's very important. We need to capture your information about the team members. So every team member needs to fill out the form. So so please go ahead and it should take you about 5 minutes or less. So please just go ahead and click the link in the chat that Andrea put there, and we can get going.
Donc, avant de commencer la session en préambule, pour toutes les personnes qui n'ont pas rempli le formulaire de participation, veuillez vous référer dans le chat. Je viens d'envoyer un link que vous pouvez cliquer maintenant. Ça ne vous prendra pas plus de 5 minutes pour remplir le formulaire. Merci.
All right, how many people have filled out the form already? Maybe you can use some of the reactions on, user reactions on Zoom. I can see Samuel, you have filled out the form before already. All right, Jimmy, yes. Anybody else? Raluchuku or Siwa or Naya? It's 01 Den or 1 Den. Have you all filled out the form already before? Or maybe you're doing that now?
Donc, pour toutes les personnes déjà présentes dans le meeting, combien de personnes ont déjà rempli le form? Veuillez vous signaler dans le chat.
All right, good. Is there anyone who is currently filling it out at the moment? So we can know whether we can wait a few more minutes. Otherwise, we'll just move ahead if no one is actively filling it right now. Anybody filling it right now?
Il y a quelqu'un en ce moment qui est en train de remplir le form pour qu'on puisse savoir si on doit commencer la session ou patienter avant de commencer.
Okay, so I'm going to assume no, and for the interest of time, we will move on. All right, but if you are actually filling it out, you can always do it as we go along, or you can do it after the workshop. All right.
Donc, nous allons commencer la session et vous pourrez remplir bien évidemment votre formulaire après la session ou pendant la session. Tout dépendra de vous.
All right, Andrea, please don't forget to help me with admitting people from the waiting room.
Yes.
Okay. All right, thank you. All right, so this is the competition outline, or let's say timeline, I mean. So we are here today, May 11. We are going to be doing the workshop on computer vision.
Donc, voici c'est notre calendrier pour la compétition. Donc, aujourd'hui, nous allons faire le workshop sur la vision ordinateur.
All right, and in the past couple of weeks, we have done a kickoff. We have also done an intro to robotics workshop about 2 or 3 weeks ago. And that has led us here. If you missed any of the previous workshops or virtual meetings, please use YouTube. We have all the recordings on YouTube.
Donc, les semaines passées, nous avons fait le lancement de la compétition. Et si vous n'avez pas eu le temps de regarder les recordings ou si vous n'avez pas eu le temps d'être présent durant les workshops, par exemple sur la robotique, ben, vous pouvez toujours avoir accès aux recordings sur le site qui est présenté à l'écran.
Yeah, and then also, not also, but this is where they're all stored. All right, so I'm going to put this in chat also for you to see. If you have missed anything, you can come to our documentation website. And if you go to resources and support, you will see the virtual meeting recordings.
Donc, vous aurez accès à ce lien en regardant dans le chat et vous aurez toute la documentation nécessaire pour avoir accès aux recordings, d'enregistrement des vidéos de précédents meetings.
All right, very good. So please make sure that you are staying up to date with all the things that we are doing so that you can get the most out of the competition. All right. All right. And then just to mention, so you can keep it in your mind, the phase 1 deadline was June 12.
Juste pour vous rappel, donc le deadline pour la phase numéro 1, c'est en juin, le 12 juin 2024.
All right, so that's in about 1 month from today. 1 month from now, phase 1 will be ending. You need to submit your solutions for task 1 and task 2 in the simulation phase.
Donc, en comptant d'aujourd'hui, nous dirons qu'il vous reste 1 mois avant de terminer la phase numéro 1 de la compétition.
All right, and the other thing to point out is we plan to organize a few more workshops, at least 1 more, or maybe even 2. But the date is not yet decided. It will depend on what people need support for. And so we'll always communicate that over Discord.
Donc, dépendamment des besoins de chacun, il y aura des workshops qui seront organisés pour rentrer un peu plus en détail sur certains points techniques. Et on vous communiquera cela sur Discord.
All right, very good. If anybody has questions, please feel free to go ahead and ask as we go along.
Si vous avez des questions tout au long de la session, de ce meeting, sentez-vous libre de poser vos questions dans le chat.
So as a quick reminder, these are the 2 tasks for phase 1 of the competition. Task 1 is autonomous field navigation. Task 2 is crop yield estimation.
Donc, comme vous pouvez le voir, c'est le calendrier, enfin, c'est l'aperçu des tâches de la compétition. Donc, sur la tâche numéro 1, vous avez la navigation autonome sur le champ. Sur la tâche numéro 2, vous avez l'estimation du rendement des cultures.
And so we have these 2 tasks, and the workshops that we're running are supposed to help you with some building blocks of maybe how to approach some of these tasks.
Donc, pour les workshops de la tâche 2, nous sommes en train de travailler sur comment établir des blocs pour pouvoir vous aider sur comment approcher la tâche.
All right, so for example, today we are going to be doing computer vision using OpenCV. And the target is that it's a very important tool to use to solve, you can use it to solve task 1 also, but specifically in doing the crop yield estimation, that is to count the number of tomatoes on the tomato plants as you're driving through, you would need to use OpenCV.
Donc, pour le workshop d'aujourd'hui, nous allons nous concentrer sur OpenCV. Vous pourrez aussi utiliser OpenCV pour résoudre des tâches résoudre la tâche 1, mais c'est plus spécifiquement pour la tâche 2, afin que vous puissiez estimer le nombre de tomates ou de plantes qu'il y a sur un plant de tomates.
All right, very good. Okay, so with that, let us go ahead and start the computer vision with OpenCV workshop for today.
Donc, nous allons commencer le workshop sur OpenCV.
And for some of you who maybe were not at the last year's final competition, this is actually an image, a picture from last year. And I know some of you on the call are in the image, which is nice to see. But this is the robot that we used last year, and this is the robot that we'll be using this year as well. So similar robot, but we'll have different sensor mounting and positions based on the task for this year.
Donc, pour ceux qui sont nouveaux dans la compétition, sur cette image, vous pouvez voir certains participants de l'année passée et le robot en fait que nous avons utilisé l'année précédente et que nous utiliserons encore cette année pour accomplir les tâches de cette année de compétition 2024.
Excellent. All right, so this is an outline for our workshop today. We'll be focusing on how to use OpenCV for computer vision. Okay,
Donc,
go ahead.
c'est un aperçu de la du programme d'aujourd'hui.
All right, so there are going to be 5 main things that we'll go through quickly. And I'll just go through them very quickly to give you a high-level idea. We'll learn about how digital images are formed and represented on a computer. That's number 1.
Donc, pour le premier point, vous allez apprendre la formation et la représentation d'images numériques.
And I'll point you to some resources on how to install OpenCV in the repository also that we are using.
Ensuite, vous allez, pour le point 2, apprendre comment installer OpenCV.
Then because our competition is using ROS, we'll talk about how to obtain images from your camera in simulation from ROS. So that is image acquisition.
Donc, comme pour la compétition, nous allons utiliser ROS, donc vous allez apprendre comment acquérir des images dans ROS et dans OpenCV.
And then number 4, we will do some little exercises to get a better understanding of digital image properties in using OpenCV.
Et ensuite, nous allons faire, pour le point 4, comment comprendre les propriétés des images numériques avec OpenCV.
And then number 5, we will do some basic image processing. You will learn how to use the available tools in OpenCV to do image processing.
Et en point 5, nous allons apprendre comment traiter des images de base sur OpenCV.
And all of the things I will do today, I will gear them towards providing building blocks for how you can solve specifically task 2 of the competition. All right.
Donc, de toutes les choses que nous ferons aujourd'hui, nous allons aussi vous apporter des compléments sur comment résoudre spécifiquement la tâche numéro 2.
All right, very good. So first of all, so that you can follow on, I've made a repository for this workshop, and it's on GitHub. So this is going to be available now and also later. So you don't feel like you need to use it at the moment. But if you like to use it at the moment, you can clone this into your local ROS workspace right away. Yeah, thank you, Andrea. So it's in the chat now. The link is in the chat. So you can, if you want to follow along, you can easily clone that repository into your workspace, and we can go ahead together.
Donc, au fur et à mesure que nous continuons dans ce meeting, vous pouvez toujours avoir accès à ce lien qui vous conduira sur le GitHub pour pouvoir avoir toutes les informations OpenCV liées au workshop de la journée.
All right, very good, very good. The workshop primarily, okay, let me see if I can, all right, well, I think that's fine. Right now, the repository just has the ROS package that we're going to be using. So you can clone that. There's a README in the repository that gives you information. But you don't need to do that right now. You can just follow along with me, and then you can always review that later on.
Donc, votre répertoire GitHub que vous pouvez accéder à partir du lien. Il y a un ensemble de packages que vous pourrez voir à l'intérieur, mais vous l'utiliserez au fur et à mesure que nous irons dans le workshop. Donc, pour l'instant, veuillez vous concentrer sur les informations qui seront données maintenant.
All right, so let's start with number one, which is understanding how images are formed and represented digitally.
Donc, maintenant, nous allons parler de comment les images sont formées et représentées numériquement.
All right, so I have two images here on the screen. The first one is showing you a digital camera. Okay, this is different from the analog cameras that we had many years ago. Some of you maybe don't know about analog cameras because you were born more recently, but digital cameras are fairly new technology actually.
Donc, sur ce slide, vous pourrez voir deux images. Donc, vous avez la première image qui vous montre une caméra numérique. Et ouais.
Okay, and so essentially how this works is that you can see from here, also from here as well, there's a similar structure there. This is showing you the actual camera. What happens is that the 3D object, light from the 3D object is captured by the lens within the camera.
Donc, comme vous pouvez voir sur la deuxième image, c'est à peu près une structure assez similaire où ça vous montre la caméra et comment l'objet 3D et la lumière de l'objet est transmise au travers de la lentille à la caméra.
Yeah, and the lens pretty much, if you remember from your physics, when you do light and optics, the lens will focus the light based on the properties of the lens that you're using. And in this case, the aperture is also a mechanism to limit the amount of light coming into the camera.
Donc, si vous vous rappelez de vos cours de physique, des cours d'optique spécifiquement, donc, dépendamment des propriétés de la lentille, la lumière sera projetée d'une certaine manière sur l'objet à photographier.
Yeah, but the main thing that really we see is that, oh, what is this? Sorry about that. The main thing that we see is that you need some sort of sensor or transducer to convert light into signals or light into something that a computer can understand.
Donc, le principe général, c'est comment est-ce que la lumière sera convertie dans un signal que l'ordinateur peut comprendre.
And so that's what we have here, the sensor. It's kind of like a light sensor, they're very common in cameras that would essentially transform this light that is hitting the substrate into a digitizer that would convert it from light to, essentially digital information to digitize the image into, in this case, is showing as a 2D digital image with different pixels, with a number of pixel sizes.
Donc, c'est pourquoi sur notre caméra, nous aurons des capteurs de lumière, c'est-à-dire des capteurs assez communs sur les caméras qui nous permettront de convertir la lumière en image digitale dans le cas d'une image 3D avec différents pixels.
It's actually very similar to how our visual faculty works as human beings or as or other animals, how vision works for them as well. Your eyes does a lot of this work, with the different components of your eyes that accepts light, reflects it on the light sensitive part of the eye, at the back of the eye. And then the brain picks up those signals to reconstruct what is being viewed.
Donc, cela nous permet de manière générale de comprendre aussi la, le fait qu'un humain ou la vision humaine ou la vision animale fonctionne, c'est-à-dire savoir comment nos yeux voient et aussi comment est-ce que notre cerveau, lui, interprète ces signaux lumineux qui passent au travers de nos yeux.
Right, but I think the main thing that I wanted to take away when you think about how digital images are formed is that you go from a 3D object in the real world, all right, like when you're holding your phone or a camera around, and through some sensing and digitization, you get a 2D image that is pixelated, right? So it's a digital image, it's like it's a matrix, and 2D matrix, or in this case, a 2D image. We'll talk about how it's formed, what its components are. But you go from a 3D object through some sensing and digitization to a 2D digital image. And that is what you have on your phone. That's what you have on the computer. That's what you have everywhere.
Donc, le focus de cette journée sera de parler de comment un objet 3D, au travers de la lentille, nous permettra de digitaliser et de la transformer, cet objet 3D, en objet 2D pour pouvoir comprendre et voir la forme de cet objet. Et c'est ce que nous voyons aujourd'hui avec nos téléphones portables.
All right. Cool. And so the other thing, one thing I was going to mention that, you have sort of like a matrix, a digital image is a matrix, but actually it is, in most cases, it is a, let's say, N by M, it's, let's say it's an A times B times C matrix. So there's a 2D matrix in three rows, you can say, or let's say in three parts. All right, so generally you would have, with this image, for example, you have red, green, and blue channels for each image.
Donc, la représentation numérique d'une image est, comme qui dirait, une matrice à 3 dimensions qui est représentée par différentes couleurs, c'est-à-dire rouge, vert et bleu.
All right, so each image you see, actually, remember, it's just numbers. Remember, it's been digitized. Usually the images are digitized from 0 to 255. You would see when we go into OpenCV.
Donc, vous verrez lorsque nous utiliserons OpenCV que la digitalisation numérique de l'image va de 0 à 2.55 sur OpenCV.
Yeah, and then so it's pixelated, meaning that your image would have a certain number of pixels. A common number that we'll be using today is 640 times 480, number of pixels that is in one matrix. And then you have maybe 3 channels of that for red, green, and blue.
Donc, vous comprendrez aussi que chaque image a un certain nombre de pixels et ces pixels sont compris dans ces 3 matrices dépendamment du nombre de channels qu'il y a donc, entre rouge, vert et bleu.
All right, so yeah, the red, green, and blue is a very common, let's say, color space that we use for storing images. You remember that red, green, and blue are primary colors. And so usually it's a very common way of representing color in images.
Donc, les couleurs vertes, rouges et bleues sont des couleurs primaires. Donc, c'est de cette manière, en fait, que sont classifiées les couleurs sur les images.
And if you remember, if you merge red, green, and blue in different intensities or in different proportions, you can get every other color, right? So the secondary colors and the colors beyond the secondary colors. But if you have the primary colors, then you can get many new colors from those.
Et sachant que ce sont des couleurs primaires, il suffit juste de faire un mix de ces 3 couleurs pour avoir des couleurs secondaires qui sont la palette habituelle que nous avons qui va vers le jaune, le violet, etc.
All right, so that's just some general ideas about how images are formed and represented digitally. The next thing would be I'll just point you to how you can install OpenCV on your computer. It's an important thing you need to do.
Donc maintenant, nous allons parler sur comment est-ce que vous pouvez installer OpenCV sur votre ordinateur.
Okay, so I'm going to give you the slides, this slide, so you have access to this later on. Usually we provide the slides with the video as well. So you can follow this link. Once you have this, you can follow the link to this page where I got this from. Also on the repository that I linked to, there's information on how to install OpenCV. So you have to install OpenCV in your computer. It doesn't come on your computer. Normally, you need to install it. Maybe you already have it because you've used it before, but make sure that you install it before you can use.
Donc, vous aurez accès à cette présentation, ce qui vous permettra en fait de cliquer sur ce lien ressource qui est sur le slide, sur cette page. Et aussi, vous avez aussi un processus dans le lien de répertoire à GitHub sur comment installer OpenCV. Et dans le cas contraire, vous pouvez toujours avoir accès à l'enregistrement et au slide qui vous permettra d'installer OpenCV sur votre ordinateur.
All right. Now, the next thing we're going to look into is, okay, so I'll just back up a little bit. So first, now we have OpenCV on your computers, or at least we know how to get it. And we have been using ROS, right? We have ROS on our computers. So how do we connect ROS and OpenCV? That is the next thing to do.
Donc là, maintenant, nous allons comprendre comment connecter ROS et OpenCV.
All right, and so we're going to do it live. I'm going to do some live coding, but before I do that, I just want to give some high-level ideas. All right, so in this competition for phase 1, we are doing everything in simulation, in Gazebo, right? The Gazebo simulation.
Donc, pour la première partie de cette compétition, nous allons faire la majeure partie de notre programmation sur Gazebo, en simulation.
All right, so in Gazebo, our robot has a camera on it. The robot has a camera in Gazebo, and that camera can be used to capture images. All right.
Donc, sur Gazebo, notre robot a une caméra, et cette caméra nous permettra de capturer les images dont nous aurons besoin pour la simulation.
Yeah, I can show you the camera here. All right, so you see there's a RGB camera on each side of the robot. You can use it to capture images.
Donc, comme vous pouvez le voir sur l'image, vous avez une RGB caméra sur les deux côtés, les deux parties du robot.
All right, and so but the format that we have images in Gazebo is different than the format that we need to use it in OpenCV.
Donc, pour Gazebo et ROS, nous avons deux différents formats et nous allons voir comment faire pour les translate.
Yeah, so to be able to convert that, we just use something called an OpenCV bridge. So it's a bridge that can take the ROS image format type and convert that to an OpenCV image type. That is the important thing that we need to know about the CV bridge.
Donc, afin de convertir nos images, le format OpenCV ou le format ROS à un format OpenCV, vous aurez besoin de ce qu'on appelle un CV bridge qui vous permettra bien sûr de convertir les formats entre les deux softwares.
All right. Yeah, there's someone raising up their hand. David? Yes.
Are you able to get me?
Yes, I can hear you.
All right, great. I have a question on using OpenCV because I'm not so familiar with it. I was wondering how easy it is to say develop a solution in MATLAB and then convert it to OpenCV. How feasible is that?
Andrea, do you want to translate the question?
Donc, la question de David, c'est de savoir si j'utilise MATLAB pour coder, comment est-ce que je peux le convertir en format OpenCV?
That's a good question, David. So up until this year, we have been supporting the use of MATLAB for PARC. We did last year. We supported the use of MATLAB for PARC. But this year we were not doing that. So I would say that it's going to be difficult for you to develop your solution in MATLAB and then convert that to OpenCV Python. Because there's really no interfacing between, at least in my understanding, and I might be wrong, but I'm not aware of any interfacing between MATLAB. MATLAB has its own image processing toolboxes, right?
Yes.
And so you'll be using the image processing toolboxes and other toolboxes in MATLAB. And it's not going to be easy to directly convert those things to Python. MATLAB allows you to export your code into maybe C++ as an executable. That also is not very easy to do, but it's possible. So I would recommend that maybe using this workshop that we are in today, you can maybe start getting to learn a little bit more about OpenCV. It's actually very easy to use. The people who developed OpenCV have done an excellent job. It's very easy to use. It's very intuitive. I would claim it is more intuitive than MATLAB's. Well, I can't really compare, but it is definitely very intuitive to use. And in this workshop, we're going to provide you some ready-to-go tools to use. Okay.
All right. Thank you so much.
Yeah, you're welcome.
Donc, pour la réponse, je dirais que il vous sera compliqué d'utiliser MATLAB et de le convertir sur OpenCV parce que MATLAB a son propre système de traitement d'image. Et la conversion du format MATLAB au format OpenCV peut être compliquée, donc il serait juste mieux de suivre en fait ce workshop pour que vous puissiez comprendre comment utiliser OpenCV, ROS et Gazebo de manière générale afin de créer une solution qui vous permettra de résoudre le challenge de cette compétition.
All right, excellent. Thank you, Andrea. So, all right, so I was going over how we merge ROS and OpenCV using the CV bridge. I think I covered that. On most of these slides, in the bottom, you'll see a link that provides you more information. If you click the link, you can read up some of the tutorial that can give more information, okay? That's very important.
Donc, vous aurez accès à cette présentation et dans la présentation, vous devrez cliquer sur les liens sources qui sont précisés dans la présentation afin de comprendre encore un peu plus le principe derrière CV Bridge et OpenCV.
All right, very good, very good. So now the next thing to mention about how we obtain images and connect OpenCV and ROS is that to do that, we need to use something called, in ROS, we need to use something called a subscriber node. Or at least a subscriber, you can say.
Donc, pour pouvoir comprendre l'acquisition d'images dans ROS et OpenCV, vous aurez à utiliser une formation et représentation des images numériques sur quelque chose appelé subscriber node.
Right. So if you have, I know some of you maybe have newer to using ROS, some of you have more experience. In any case, an important way to communicate in using ROS is this idea of topics. One part of your code can be publishing something to a topic, and then another part of your code can be subscribing to that information from that topic.
Donc, votre code aura différentes parties, c'est-à-dire celle de la publication de l'image et celle de subscription de l'image.
All right, so for example, in our case, our camera, let's say our camera driver node, which is already existing in Gazebo, is going to be publishing image information on a topic, all right? And then what we're now going to do is to write our own image subscriber, like this one here or this one here, that will be subscribing to that topic. And so we can collect those images, and then we can maybe process the image, or we can save it on our computer, or we can do whatever we want. So this is what we're going to do.
Donc, vous allez avoir publié l'information imagée sur un thème bien précis, et ensuite vous devrez écrire l'image sur un différent type de subscriber, et tout dépendra de ce que vous choisirez dans votre code.
All right, very good. So next thing actually is to do a live coding practice, not practice, but we can work on it together. So just give me 1 minute. Let me organize my space here.
Donc, nous allons faire un coding live, ce qui vous permettra de le faire en même temps que Kenny, de coder votre OpenCV.
Give me a moment. Okay. And as we go along, if people have questions, you can always either ask in the chat or unmute yourself, like we had David do a moment ago.
Donc, si vous avez des questions, n'hésitez pas à ouvrir votre micro ou juste écrire.
All right, very good. Okay, so hopefully you can see my screen again. So this is going to be our environment. Okay, let me bring the chat so I can see. Make sure I can see anybody put something in the chat. All right, so just trying to get organized here. Okay, so this is the OpenCV 2024 repository that I asked you to clone. So I already have it here. And I have my 2 terminals here so that we can run things.
Donc, voici notre environnement de coding. Et pour cette année, il a utilisé la version de OpenCV 2024.
All right, so the first thing we're going to do is to create our image subscriber. Okay, now I'm going to go through this, maybe also give you some ideas on how to write Python code for your applications. So the first step would be to import all the necessary libraries.
Donc, la première chose à faire maintenant, ce sera de créer un image subscriber. Et ensuite, vous aurez quelques idées sur comment écrire votre code Python sur le software.
because we are using ROS2 and Python, we would import RCLPy, and then we also import RCLPy.node to get the ROS node.
Donc, parce que vous êtes en train d'utiliser Python, vous devrez importer certaines librairies sur votre environnement de travail.
Let's see, and then we will import OpenCV also, all right?
Donc, ensuite, vous allez importer OpenCV.
We'll also import CV Bridge. Remember I talked about CV Bridge, we need that.
Donc, ensuite, vous allez importer CV Bridge. Si vous vous rappelez, c'est ce qui va permettre en fait de convertir les formats entre ROS et OpenCV.
All right, then every Python code should have your main initialization here. So we have main. This is where the code is actually going to run from. All right. And so now I declared a main function. I will go and define the main function.
Donc, comme tout code Python, vous allez devoir définir la fonction principale.
All right, so this is just generally the structure that you should always have. That is just the primary structure you should always have. But now so all our code is going to be inside the main, all right, the main function. When this Python script is called, it will check if this is the main, it will come over here and run everything inside here. So in this case, it will run main function, okay? Right. All right, so the first thing we will do is to initialize the RCL Python, initialize RCL Python essentially. So RCL py.init, okay.
Donc ensuite, vous allez premièrement initialiser votre librairie RCLPY.
And what we want to do is to create an image subscriber node. All right, that's what we want to do.
Donc après initialisation de votre librairie, vous devrez créer un image subscriber node.
So we can call it image subscriber. And then we need to create one. Now we have not, this is going to be an instance of a class. We haven't created this class, but we can keep it this way. Okay. So we're going to come over here and create that class, right? This one that we had here. That's going to be a image subscriber.
Donc ensuite, vous allez créer cette classe pour image subscriber et ensuite vous pourrez revenir pour ajouter plus d'informations au fur et à mesure que vous écrirez votre code.
Okay, so this obviously I'm assuming that you know a little bit about object-oriented programming. If people don't have much experience with that, you can let me know. I can provide some resources that can be helpful. But I'm going to assume that you are somewhat familiar with Python programming with object-oriented format.
Donc, si vous avez des problèmes sur l'orientation d'objets par OOP, donc vous pourrez toujours lui envoyer un message dans le chat pour qu'il vous donne un peu plus d'informations.
All right, so usually in ROS, we will do what we call spin. All right, so spin is a way for us to make sure that our image and our node keeps keeps collecting subscriber information. Sorry, well, yes, subscriber information. All right, so we'll use this function called spin to make sure that our image continues to function continuously.
Donc sur ROS, vous avez cette fonction qu'on appelle spin qui vous permettra en fait de vous assurer que votre image continue d'être dans la node et ça vous permettra de continuer à collecter des informations de l'image subscriber.
And then more recently in ROS2, it becomes quite common to explicitly shut down the node when you are done, or like destroy the node, I mean, when you're done.
Et ensuite, la fonction destroy node vous permettra de mettre un point final à votre expérience ROS.
All right, so these are the 5 main steps that you usually need to do for a subscriber. It's actually very simple. What we're just doing here is we're initializing ROS2 Python library, and then we are creating an object of our image subscriber. Okay, you go ahead, Andrea.
Donc actuellement, vous êtes en train de initialiser ROS et la librairie Python afin de créer un image subscriber.
Yeah, and then here we're saying, okay, this image subscriber should continuously collect information from the callback function, that we're going to write that very soon. It says, okay, continuously process that callback function.
Donc sur la ligne 26, le code dit qu'il faudra en fait continuellement collecter des informations et rappeler à plusieurs reprises cette fonction-là. Voilà.
And then these two are just to, once it is done, it should end or shut down or destroy the node. Okay.
Et donc, les deux dernières lignes, de la ligne 28 à la ligne 32, c'est juste pour boucler la boucle de collection d'informations.
All right, very good. So now the next thing for us to do is to create the next thing for us to do is to create the image subscriber node. Sorry, not node, the class. So I'll just write a couple of, yeah, go ahead.
Ensuite, la chose suivante à faire, c'est de créer l'image subscriber node.
So we are inheriting from the node class, and we can put the name of the subscriber of the node here, subscriber. Yeah, so we give it a name. The name is image subscriber. So let's see.
Donc là, vous allez nommer en fait la node.
All right, so initialize the node with a name. Then once we have a name for our node, the next thing to do is to, okay, so before I move on, actually, I know some people, depending on how much you have experience with Python and also with ROS, some of this might be very new to you, okay, and I want to acknowledge that. If it is very new to you, before I move on, let me just point you to this resource. Most of the things that I'm covering today, actually, we have, let's see, where is it? Here. Okay. We have these 2 tutorial lists, okay? So you really need to, if you're new to ROS or to Python, but ROS specifically, there are many helpful resources online. These workshops cannot really go into all that detail. This is mostly to give an idea of how to apply the things that are available to the specific task.
Donc, ce workshop n'est pas exhaustif, ce qui veut dire qu'on n'aurait pas forcément accès à toutes les informations Mais si vous voulez plus d'informations, plus en détail, vous devrez rentrer dans le lien de Getting Started with Ross. Et là-bas, vous pourrez voir les 2 tutoriels qui vous permettront de comprendre encore un peu plus en détail l'utilisation de Ross et voilà.
Yeah, so this is, I mean, using Python, programming in Python and using ROS is very exciting, but it requires you to spend some time to really study and practice. So I would really recommend that you, for example, you can use on YouTube and watch some of these videos. It explains everything that I'm doing actually. So you can see how to write a ROS2 subscriber in Python. You can see how to do object-oriented programming in Python. And so if it's new to you, that's okay. We appreciate that. I'm excited that you love to learn. But there's amount of work that you need to do in order for you to catch up. Okay, so we have provided some of these resources. Specifically for object-oriented programming, I would see if this resource is not sufficient and maybe I can provide another one. But even if we just go through these videos, they are very short, no, they're not very short, but like 20 minutes long on YouTube, and practice as you are following, you should be able to cover many of the things.
Donc, essayez vraiment de prendre le temps de pas de suivre toutes ces vidéos. Si vous avez un niveau débutant sur l'utilisation de ROS, ça vous permettra en fait de rattraper un peu votre retard et comprendre la suite de la compétition.
Yeah. All right, so that's just to mention that in case some people might be getting lost as we go through the programming. But in any case, even if you are new to it, just pay attention, ask questions if you have any questions. As you're watching, you're picking up some things that when you go back to study, you can also understand more. Okay.
Donc, vous pouvez poser vos questions dans le chat. Vous pouvez activer votre micro si vous avez des questions à poser pendant la session. Ça vous permettra en fait de comprendre un peu plus. Si vous avez un problème, ouvrez votre micro et posez votre question.
All right, so I'm going to go back here. Now, let me just use the same thing. All right, so once we are now here, we create the subscriber object. Okay, so we'll use create subscription. We use that function that's already available. There are different things we need to provide in defining that thing. You can see all the different options here. I'll just write what our choice is. We need an image. All right. Callback function. And then usually we set the queue size. All right, so there are a couple of things I put here. Let me go back here and define some of them. Okay, so usually when you're creating a subscriber, you need to give it some certain things. The first thing is the message type that you are going to be listening to, all right? In our case, we are listening to an image. So,
donc, lorsque vous allez créer un subscriber image, devez en fait écrire un message. Et dans notre cas, le message, c'est image.
All right, so we will include that as this is the image type that we're using. And then the topic name, we don't yet know the topic name. I will show us how to check the right topic name.
Donc, nous n'avons pas encore un thème principal pour l'image. Donc là, il va vous montrer comment en fait choisir un thème imagé pour le code.
Right, very good. And then usually we want to call this here just to prevent it from being unused. So that this is a very common step that we follow for creating subscribers. And so we just do it that way. Okay.
Donc, cette étape est assez commune lorsque vous voulez créer une image subscriber.
The last thing that we need to do here at the moment is to create our CV bridge object. All right, so our CV bridge object, so let's call it let's call it.
Ensuite, là, nous allons créer notre CV bridge object.
CV bridge. Okay. All right. Very good. Okay, so that is how we initialize. That's most of the things we need. Then the main other thing that we do in a subscriber, and if you have gone through some of those tutorials, you know the next thing to do is to write your callback function. All right, so there's a callback function I wrote here. We need to write out that callback function. So let's say message data.
Lorsque vous allez regarder les vidéos YouTube dans le lien de PARC, vous verrez en fait, vous comprendrez un peu mieux pourquoi est-ce qu'on utilise la fonction callback pour le image subscriber node.
All right, so what happens in ROS is that when this script is run, it will try to find this image topic, this image topic, and it will try to subscribe to that topic. And each time it receives an information or data from that topic, it will call this function. That's why it's called a callback. Each time it receives data from this topic, it will call the function.
Donc, à chaque fois que la node va recevoir une information de ce topic qui s'appelle self-image, donc il va la fonction callback va rappeler en fait cette fonction à image subscriber afin de collecter encore les informations.
All right, so once we receive a message and we go into the callback, I want to maybe put some message just to show that, yes, we are receiving a message, something like that. So I can say something like that, receiving image frames. This is just a string that we're going to show on the screen, in the console, in your terminal.
Donc là, il vient d'ajouter une ligne qui peut permettra en fait de display sur votre console un message qui vous dira que l'image a été reçue par la node.
The next thing to do, remember, is that we need to convert from ROS image message type to OpenCV image, and that we are going to use the CV bridge.
Donc là, maintenant, vous allez créer une fonction qui vous permettra de convertir les images ROS en images OpenCV, c'est-à-dire utiliser la fonction de CV bridge.
So there's a function called image message to CV2. And we use that to convert the image.
Donc la fonction img msg to CV2, c'est cette fonction-là qui vous permettra en fait de faire la conversion entre ROS et OpenCV.
All right. And then now this is an OpenCV image type. Okay. So now we can use OpenCV functions to process that image.
Donc maintenant là, c'est une image de type OpenCV et du coup, vous pouvez utiliser la fonction, des fonctions OpenCV maintenant pour utiliser cette image.
or my monitor is okay. So I just changed the name of this OpenCV from OpenCV2 to CV, so it's easier. So that it's easier for me to use, but that's fine. So we use imshow. Imshow is the function we use to display the image.
Donc ensuite, afin de faire display l'image sur votre console, vous allez utiliser la fonction eShow.
All right, so and then so that's pretty much it. Let me look over it. So it's actually it's not a very long piece of code. And this is our image subscriber. Okay. Each time we receive a message from Ross, it will call this function. This function will print something on the console saying, oh, I'm receiving a message. Then it will use this function to convert the Ross message type to OpenCV message type. And then this will this will show the image. And then this we usually use in order to like just maintain the window in OpenCV.
Donc, à chaque fois que vous recevrez un message de Ross, ça va rappeler les fonctions que vous avez précédemment établies dans votre code. Et ces fonctions, en fait, ils vont l'imprimer dans la console et vous recevrez le message que vous avez prédéfini sur votre ligne 35. Et ensuite, ça devra normalement, si vous avez bien écrit votre code, vous montrer l'image que vous avez convertie dans votre code ROS.
All right, so if you are following along with me, we should be able to run this code. This, remember, is in the OpenCV workshop 2024 folder in the repository. So I can go there and let's see, I'm here. So I can actually do call cone build. All right, I can build. Let me see if I'm building the right thing. All right. So I can do call cone build, and I will remove this just to make sure that we're also on this area right now. So I can build and everything built. I have a couple of other things there, but it built the OpenCV. Okay.
Donc là, vous avez un ensemble de noms que vous devez utiliser pour dans votre console, littéralement.
All right, and I can also source my workspace there. Remember, it's always important to source your workspace. Source my workspace.
Donc ensuite, vous allez introduire des sources pour dans votre espace de travail.
All right, so then the first thing I want to do is to run task 2, all right? Because task 2 is the task 2 launch file is what will create. Let me just show you what I mean. All right, so we come to task 2. The first thing to do would be to run this task 2. That will show this. All right, so I can copy that. Come over here and run task 2.
Donc, vu que le but principal de ce workshop, c'est par rapport à la tâche numéro 2, et vous pouvez aller dans le lien de PARC 2024 pour pouvoir faire play le code, en fait.
Yeah, I know we're having some discussion on Discord about some teams. Some people are having some issue with the robot showing up with the wheels. So I'm still trying to debug that problem. But that shouldn't affect, I don't expect that to affect you having access to the camera information though. If it is affecting you, please let me know. I don't expect it to affect you. I'm going to try and work on that today so I can get you some feedback. I'm trying to recreate the problem and then find a way to solve it on my own computer. Because everything is working fine on my computer.
Donc, quelques personnes reportent le fait qu'ils n'arrivaient pas à avoir accès à la vision de la caméra, principalement et que ça leur montrait les roues. Donc, il est toujours en train de travailler sur comment débugger cette partie-là, mais ça ne devrait normalement pas vous empêcher d'avoir les informations de la caméra. Et si vous avez des problèmes sur les informations de la caméra aussi, vous pouvez toujours le signaler pour qu'ils puissent le débugger.
All right, very good. So this is what it should look like. You know, the robot is going to be moving through this row, and then the two cameras on each side will be passing the tomato plants, and you should be able to see the tomatoes as you're moving in the image frame.
Donc, lorsque vous allez utiliser ce code, normalement, vous devrez avoir cette même vision caméra-image là, qui vous permettra de voir en fait sur les deux côtés du robot les plants de tomates.
All right, but this is in ROS. We want to bring it into OpenCV. All right, so I'm going to just run it again. I'm going to try and reduce the speed. I hope you know that you can actually change the speed. I'm going to set a low speed, 0.1. I'll run it all over again, and we should be able to see it. And then now I'm going to run our code, the code we just wrote. And that will be subscribing to the image. Oh, okay, actually. Just wait.
Donc, notre but principal, c'est de le convertir de ROS à OpenCV. Donc, nous allons run le code que nous avons écrit précédemment pour voir s'il marche.
Yeah, the first thing that we haven't done yet is that we haven't set what the image topic should be. Remember, I set it to none here. Okay, I want to show you how to find it. So what you usually do is to say, okay, Ross, to topic list. That'll give you a list of all the topics that are available. And for now, we care about, let's say, the camera, left or right camera image, right? Because we can see, we care about either the left or the right camera image. That's what we're showing here in our viz.
Si vous vous rappelez, sur la ligne 19, nous n'avons pas écrit en fait d'image topic et vous devez normalement aller sur votre console et taper ROS topic L, ce qui vous donnera la liste en fait de tous les topics images disponibles. Et de là-bas, vous pourrez sélectionner celui dont vous avez besoin.
So I'm going to take this left camera image raw. I'm going to use that one. Okay, I'm going to come here and paste it here. All right.
Donc, dans la liste, Kenny a choisi left camera image raw.
All right, so that's what we're going to use. We're going to be listening to this topic and collecting that information, okay, into the script. All right, so let's run it again, and then this time around, I think we should be able to run this script and see what we get.
Donc, après avoir sélectionné l'image topic qui est left camera image raw, donc on va essayer de run encore une fois le code pour voir qu'est-ce qu'on a comme résultat.
Yeah. Mm-hmm. All right, so I'm running that again. The gazebo takes a few minutes before it launches. Actually, it's fine. So the command will be this. I'm surprised I don't see. I'm surprised I don't see that. Mm. Okay, just okay, so now we get it. Yeah, I was trying to do launch instead of run. All right, so you see we're getting receiving image frames, and then this is our OpenCV window.
Donc, comme vous pouvez le voir, vous avez la fenêtre OpenCV après avoir run le code qu'on a écrit il y a quelques minutes.
All right, so that's each time you see this printout, it means that it is actually calling that function. Okay, each time you see this printout, it means it is calling this callback function and printing this thing, right? And then it is showing the image, updating the image that we have there. Okay.
Donc, à chaque fois que vous voyez qu'il est écrit image subscriber, la fonction image subscriber, c'est le fait en fait que le code continuellement rappelle la fonction et c'est ce qui fait en sorte que vous voyez sur votre console image subscriber multiple times.
Right. One thing you might notice though is that these two images are supposed to be the same because this is in OpenCV and this is in ROS and RViz. But you can see that this image is the color is a little bit distorted, right? Looks like there's some kind of filter on the image. And yes, that is true. So that's something I noticed actually. I didn't know about this before. But it's based on the arrangement of the channels. Okay.
La distorsion des couleurs, c'est-à-dire, comme vous pouvez le voir sur le OpenCV et sur le ROS, les couleurs ne sont pas similaires. Donc, tout cela, dépend vraiment du positionnement de votre code dans votre script.
So apparently what happens is that let me show you here, in ROS, the image is the regular way, it's RGB. But in OpenCV, as the channels are R and then G and then B, in OpenCV though, it is by default it is BGR. All right, so we need to take note of that.
Donc,
what we do here is, yeah, go ahead.
Donc, l'arrangement des couleurs primaires sur ROS et sur OpenCV sont assez différentes. Donc, sur ROS, vous allez voir que c'est écrit RGB et sur OpenCV, c'est écrit BGR.
All right, so once we make that update, we say, okay, look, when you are converting from ROS to OpenCV, convert it into BGR, then we will see that we will get a more consistent thing. All right, so let me close this and run it again.
Donc,
right,
vous devez maintenant faire la modification dans votre code pour respecter la chronologie de OpenCV.
All right, so now you can see it's the same, let's say, color form as you can see in RViz. Okay. All right, so what we've done so far is to write our image subscriber. Okay, so this is the very important step that you need to take. So let's see.
Donc, ce qu'on a fait aujourd'hui, c'est d'écrire notre image subscriber.
All right, so then the next thing we're going to do, and then again, if you have any questions as we go along, please feel free to ask. The next thing we're going to do is to practice some digital image operations. Okay, so do some digital image operations to help us understand the properties of digital images. Okay, so we're going to do that again through some live coding. We can do it together. All right, so I'm going to come over here and start over. And this code is not going to be, does not need to be, oh, actually one thing I forgot. One thing I forgot. So here, I showed you how you can show the images in RViz, I'm sorry, in OpenCV, but actually we need to be able to store the image so we can do some post-processing. Okay, so we need to store the image maybe on our computer from the camera in Gazebo so we can do some post-processing. Okay, so what does that mean? Let me run this again. I'm not run it. So what that means is that, you know, we are subscribing to the data, but we need to be able to, do you know what that is? We need to be able to store the images on our computer. Okay, so that's what we're going to try to do now.
Donc maintenant, nous allons nous attarder un peu plus sur comprendre les propriétés des images numériques avec OpenCV. Et une chose à se rappeler, c'est que nous devons être capables aussi de conserver les images que nous avons précédemment processées dans notre ordinateur. Donc, on va utiliser la caméra de Gazebo pour faire encore quelques processing sur les images.
So in the interest of time, I'm just going to, I just copied and pasted. I copied and pasted some code that I already wrote before. So we can move more quickly. I can explain it very briefly. What we're doing here is we're just going to say, okay, as the robot is moving, we want to say, okay, we can decide when we want to save the image. So because we have the image here, img. So I'm saying I'm going to save the image in, this is an absolute path to this directory on your computer. But the high level thing anyways is that I want to save the image with a given name each time I press the key S. That is it. Okay, so don't think too much about this. You can use it on your own as well. It might be helpful for you. You can just copy and paste it.
Donc, vous avez la possibilité de juste copier et coller cette partie de code, ce qui vous permettra normalement de rappeler la fonction image à chaque fois que vous allez presser la touche S.
All right, so initially I already had some images. I'm going to just delete them. And then I will, you know, now this images folder is empty. We're going to save some new images together now, okay? So what we'll do is that on one terminal, we will run the task 2, and then other terminal, we will run this code.
Donc là, il a supprimé les précédentes images qu'il a pu collecter du précédent test. Donc là, maintenant, il a supprimé les images et on va run la première tâche, c'est-à-dire le code précédent sur la console numéro 1 et ce nouveau code avec cette nouvelle implémentation sur la console numéro 2.
All right, so now what happens is that once I press S, you know, it will save. So I'm just going to collect some, I want to collect some data.
Et là, normalement, vu que vous avez écrit la fonction selon laquelle l'image doit être capturée lorsque vous appuyez sur la touche S, ben, vous allez regarder l'image et ensuite capturer à votre goût les images.
So I've pressed S 2 times now. That's why we have 2. And then I'm going to press S one more time. I'm pressing S when the tree is in the middle of our image. So like here, I can press S again. And then we have these 3 images.
Donc, il presse la touche S à chaque fois que la plante se retrouve sur le milieu de l'image. Donc, c'est tout à fait vous qui cliquez sur la touche S pour pouvoir capturer l'image, ce qui n'était pas le cas sur le code précédent.
All right, so now we have this one. This is the first one I got. This is the second one. This plant doesn't have any tomatoes. And then this one has some. Okay, so I got 3 images saved.
Donc, après la lecture du code, il n'a capturé que 3 images.
All right, so I was gonna come here. All right, so then I think the next thing I wanted us to do was to look at how to do some basic operations. I think that's where we were. Okay.
Donc ensuite, nous allons voir comment faire des traitements d'images de base sur OpenCV.
So again, as I mentioned before, the first thing to do whenever you're writing some Python code, usually, would be to, create and define your main. Okay, so always do that. And
Donc
also,
là, vous pouvez juste utiliser la procédure normale pour un code Python.
then import any necessary libraries. So for this one, we're not going to use this example. We're not going to use ROS. We're just using only OpenCV and processing the image that we have saved.
Donc là, pour cette étape, nous allons juste utiliser OpenCV. Nous n'allons pas utiliser ROS. Donc, c'est toutes les images que nous avons pu prendre de la précédente expérience, du précédent code, que nous allons utiliser sur ce code-là.
All right. The first thing that we need to do is we need to read the image from the directory. Okay, so read image from the directory. Okay, so right now the image is in images folder. Okay, so it will be something like this, images, and then the name of the image. So let's say we use image, let's say we use image 0. We use image 0.jpg.
Donc là, vous allez faire l'image de destination, c'est-à-dire vous allez prendre la destination de l'image et l'écrire sur votre code.
And then to show the image, we'll use imShow as image show. So this will probably be the simplest OpenCV code that you can ever write.
Ensuite, vous allez utiliser la fonction imShow qui vous permet en fait de display l'image.
And then, so that's pretty much it. I can now come down here, or we can, I think I can come here and we can run this code just in Python. Okay, so because this is just in Python, we can run it just in Python. But let me do it here so everybody can see. Instead of doing it.
Là, vous pourrez simplement lire votre code en Python.
Open CV. Okay, all right. So then we will say Python. In my case, the command is Python 3, and then it's let's see, it's basic image operations. Basic image operations.py.
Donc, dans la console, vous allez préciser le type de pour finir. Et ensuite, vous allez.
Oh, Andrea, your volume is really low. Hello?
Can you hear me now?
Yeah, it just went really low when you were talking.
Ok. Donc, pour cette partie, vous devez rentrer dans la console. Et dans la console, vous allez devoir écrire le type de Python que vous allez utiliser. C'est-à-dire pour Kenny, il utilise le Python 3. Donc, vous allez écrire le type de Python qui vous convient et qui est que vous utilisez actuellement. Ensuite, vous allez écrire le type de fichier, le nom du fichier et dans la console.
Oh yeah, and then yeah, this sometimes happens. Okay, so usually to help with killing, let me just come over here. This is usually helpful to close the code. You can always copy and paste this to say, okay, if you press S, you can close all the windows. Otherwise, I've noticed that it's difficult to close.
Donc, dépendamment de vous, vous pouvez choisir de rajouter l'option appuyer sur la touche S afin de fermer toutes les fenêtres qui pourraient pop-up lors de la lecture du code.
All right. So then when we press S, it closes. Okay, cool. All right. So I can show you the image one also. I can change this to image one and run this again, and you get image one. Okay, this is already saved. So we're not using ROS right now. We already saved these images. Now I can also do image two. This is image two. We can see that and then press S, close it. All right.
Donc là, maintenant, vous pouvez changer à votre convenance l'image que vous voulez voir. Et lorsque vous appuierez sur la touche S, la fenêtre fermera automatiquement.
All right, so there are a few things I want us to see. Maybe we can inspect the data type. Okay. And so what we can do there is we say, okay, what kind of data type is this? Let me just copy and paste this in interest of time. We can print the data type, and then we can also print the image shape. Okay, so I'm just showing printing the data type and also showing printing the image shape. That's what's the size of the image.
Donc ensuite, vous allez juste faire un copier-coller du type de données et le type de forme de votre donnée, de la donnée d'image.
When we see that, we can see the printouts here. Okay, so this is the data type. The data type is a NumPy array. Okay, so it's a matrix. In this case, it's a 480 by 640 by 3. Remember, we talked about how digital images usually have multiple channels. So this one has 3 channels, right? And each channel is a matrix of 480 by 640.
Donc, si vous vous rappelez, on avait parlé du fait qu'une image numérique a habituellement trois channels, c'est-à-dire que c'est d'habitude 480, 646 et 3.
All right. All right, so that's an important thing. Other things that might be interesting to do is to say, okay, we know that there are 3 channels. Can we see the different channels separately? All right, so that is maybe called splitting the channels. We can try and split the channels. All right.
Donc, dans votre code, vous avez la possibilité de diviser les channels individuellement.
All right, so to do that, we're going to do, first of all, we're going to use matplotlib, which is another function, hopefully, another library. Hopefully some of you are familiar with matplotlib. It's a lot for plotting. If you're familiar with MATLAB, it is very similar for MATLAB in plotting. Okay, what we're doing here, we're converting this image. Remember, it is in BGR, that is the OpenCV format. We're converting it back to RGB because matplotlib uses RGB.
Donc ensuite, vous allez utiliser la fonction matplotlib qui est assez familière pour les gens qui ont l'habitude d'utiliser MATLAB. Et dans cette fonction, vous allez en fait convertir l'image de BGR à RGB parce que spécifiquement, cette fonction demandera en fait d'utiliser le type d'image en RGB plutôt qu'en BGR.
All right, and then right, so then we're going to use this function called split to convert. Oh, sorry, my screen is to split the channels into three. Okay, we're going to use this to split the channel into three.
Donc, vous allez utiliser cette fonction split pour pouvoir diviser les channels dans 3 parties différentes.
And then we're going to plot the channels. I'm just gonna come here. So because of the sake of time, I would just copy and paste some code that I've written already for this. So I want us to get to some level today. Sure. But all this code will be available on the web in the repo once we're done, so you can use it. Let me see if I can run this.
Donc, sur cette portion de code, en fait, vous allez créer un graphe de chaque image, de chaque channel, je dirais.
All right, there we go. So this is what I want you to see. So we're plotting the original image, and then we're plotting the 3 channels, the RGB or BGR channels in this case. All right, so these are actually the 3 channels that make up this full image. All right, so this image is actually a combination of the 3 channels. Okay, so that's an interesting image to see. So like I mentioned before, each time you see an image, it is actually based on different channels that are being combined together.
Donc, comme vous pouvez le voir, ces trois chaînes différentes sont la base littéralement de la création de cette image originale que vous pouvez voir sur votre gauche.
Okay. I don't have any question. No one is asking questions. Am I moving
Question?
too fast, maybe?
N'hésitez pas à ouvrir votre micro si vous avez des questions.
Does anybody have any questions? Okay, so that was for showing splitting the images. The last thing I want to do before we try to start wrapping up is I want to show us how to convert to different color spaces and to do some image thresholding. Okay.
Donc, avant de terminer le live coding, il va vous montrer en quelque sorte comment faire des espaces de couleurs.
All right, so oh, okay, I think actually this should be in the slides. Let me go back to my slides. All right, yeah. So so far I talked about RGB or BGR as a primary color space. There are other color spaces. A very common one also is HSV. It is hue, saturation, and value.
Donc, comme on avait parlé précédemment, vous avez différents types de couleurs primaires, c'est-à-dire le format RGB. Et vous avez aussi la possibilité de voir le HSV qui veut dire saturation, valeur et H-U-E.
Okay, and so sometimes there are many other ones. Let me show you this image. These are all the different, not all, but these are some of the different color spaces. So this is the, RGB, BGR. This one is HSV. This is gray. This is XYZ. This is YCRCB. There are many of them. You can check on this link to see all the different types that you have in OpenCV. So we have many color spaces. And once you convert to different color spaces, you can see different things, different properties of your image.
Donc, vous pouvez accéder à plus d'informations sur Color Space en cliquant sur le lien qui est dans le slide de cette présentation. Et ça vous donnera en fait plus d'informations sur les différentes propriétés d'image que vous pouvez avoir avec OpenCV.
And what's really important in choosing color space is that sometimes when you want to do some masking to remove all the colors except one particular color, and then for you to detect something in an image, sometimes it's easy to do that in one color space as opposed to another one.
Donc, dépendamment de votre utilisation de l'image, si vous voulez peut-être masquer quelque chose ou bien rendre plus visible une information sur votre image, il est important que vous connaissiez et que vous sachiez comment utiliser les color space pour pouvoir le faire sur OpenCV.
So that's sort of the main thing. So for example, what I'm showing you here is an example of what you might need to do for task 2, right? This is an image. I converted it from the BGR to HSV. This is the HSV color space.
Donc là, comme vous pouvez le voir, il a converti RGB en HSV, les deux premières images que vous voyez à gauche, de haut en bas.
And then in the HSV, I can see, oh wow, it's easy to separate the tomatoes from this background, right? And from other things. So then I can use some thresholding on my HSV values to remove other things and get this.
Donc, comme vous pouvez le voir avec l'utilisation de HSV, vous avez la possibilité de déterminer littéralement le fond de l'image et les fruits en eux-mêmes. Donc, vous faites la différence. Et en utilisant le maintien de votre image, vous pouvez déterminer spécifiquement quels sont les éléments de votre image que vous voulez avoir en priorité sur votre color space.
And then I can now use some bit operations to merge or to combine these two together to get this, right? So now you can see I'm going from our original image to an image that has singled out each tomato plant. I'm sorry, each tomato fruit here from this image.
Et donc, après avoir choisi votre color space, vous serez capable, en fait, avec un peu plus d'ajout d'effets et d'informations, d'opérations, vous pourrez maintenant être capable de différencier de votre image originale les fruits, les plants de tomates, en fait, que vous devez identifier avec votre caméra.
All right, so this is why using OpenCV is very powerful. All the functions that you need to do all these operations are already available. All you need to do is to maybe do some tuning of some of the thresholding parameters. Everything else is already available.
Donc, ce sont les raisons pour lesquelles l'utilisation de OpenCV est vraiment importante, ce qui vous permettra d'avoir des résultats plus palpants pour la suite de la compétition.
All right, so for the next few minutes, what I want to try to do is just to show you how to do some of this color space conversion, and then how to do some thresholding, okay? And then we can call that a day.
Donc, comme dernière opération, nous allons apprendre à comment déterminer ses color space et aussi comment faire le maintien de l'image.
All right, so to do color space conversion, I want to convert our image that is in RGB, for example, to HSV, like I showed you. What you use is this CVT color function, that's convert color.
Donc, pour pouvoir utiliser color space, vous allez devoir commencer à faire une conversion d'image en RGB, par exemple HSV. Et de là, vous pourrez avoir une conversion d'image de votre code.
All right, so it's very simple. It's just one function actually. And so I'm saying, okay, convert image, and then I'm saying, what is the conversion? It should be from BGR to HSV. That's all we need to do. I need to convert it to become a HSV image. Then I'll plot, I will display both of them.
Donc, dans votre code, vous allez écrire la fonction image HSV qui vous permettra maintenant de faire la conversion entre BGR et HSV. Et ensuite, vous allez display les deux images sur votre console.
Send that out, and then we can run this now. All right, there we go. So we have the original image and we have the HSV version of the image.
Donc, quand vous allez run votre code maintenant, vous allez voir les deux fenêtres qui vont pop-up, donc l'original et la HSV image.
All right, so that was pretty simple. The next thing that we can do is to do some thresholding. Okay, so usually to do thresholding, you use a function called in range. Okay, so that is only display what is within a particular range. And then you can give the actual color ranges. Okay, something like this.
Donc, ensuite, pour faire le image thresholding, donc le maintien d'image, la conservation de l'image, vous devrez utiliser une fonction qu'on appelle inRange. Et de là, vous pourrez déterminer les ranges de chaque image, c'est-à-dire les couleurs minimales et maximales.
All right, so we're saying, okay, only display components of the image that are within this range. And remember that our image is three channels, so the minimum and maximum will be for each channel, right? Display only what is within the range for each of the three channels. That's why we have three numbers here between zero and 256. Sorry, 255. That's 256 numbers, 0 to 255.
Donc, pour ne pas oublier, une image a donc 3 différentes channels. Donc, vous allez devoir écrire le maximum et le minimum pour chaque channel. Donc, vous avez 000 pour la première channel et 133 à 78. Donc, c'est le minimum de chaque channel. Et ensuite, pour les couleurs maximales, vous avez le 27. Donc, c'est le maximal de votre channel numéro 1, et etc. jusqu'à 255.
All right, so I will tell you how I chose these values, but for now, just assume that these are some values. You can play around different values. After you do that anyways, you will get a new image. You can now display the image using this display. All right, so let's see what it is.
Donc, ensuite, vous allez utiliser la fonction inShow pour pouvoir display votre thresholder.
All right, there we go. So this is what we got. Okay, so for our given for the values of minimum and maximum we set for 3 channels, we're able to get this. Okay, from here. Okay, now I can go here and change some of the things and see how it changes. So we change this. and run it again. You see it changes. All right.
Donc, vous pouvez aller dans votre code et modifier la range de couleurs. Donc, ça va directement être appliqué sur votre image. Vous allez juste rerun le code une seconde fois pour pouvoir voir les différences qui sont appliquées aux images.
All right, so you can see you can play around with those numbers, and the numbers are just to determine which range of that channel information do you want to display. All right, so you need to do a lot of tuning here to get what would be good to only isolate the crop itself.
Donc, vous pouvez prendre votre temps pour trouver la bonne combinaison, c'est-à-dire la bonne combinaison de couleurs pour pouvoir avoir le résultat que vous voulez.
Okay, so this is not too bad, even though we can still see some parts of the stem of the tomato plant. So we don't really like that very much, but it's not too bad. At least we're getting a good view of the tomato plants and the tomato fruit. We can go ahead and try with another image. Remember, we had 3 images. We can try with another image. And you see.
Donc, vous allez pouvoir faire cette même opération avec les 3 différentes images que vous avez déjà inclus dans votre code. Donc,
yeah, so we can try another image, and you see this is not too bad. The only problem is that we are getting the stem, which could be a problem depending on how we want to do our counting of this. All right, so we might need to think about how to solve that issue. That's something that you can try to do. The last thing I want to show finally is well, not the last thing, but almost the last thing, is using the bitwise AND to do some masking. Okay, so we can, let me show you what this does. All right, you see that? So that does a combination. It does an AND combination of these 2 image, not these 2, these 2 images, so that you can see everything that is in white in this image. Every area that is in white in this image is displayed here in this image, in this space. So you can see the fruit there.
Donc, avec cette fonction masque, vous serez capable en fait de retranscrire tout ce qui est en blanc sur l'image HSV sur le plan masque, ce qui vous permettra en fait de ramener l'image originale à ça pour que vous puissiez comprendre en fait quelles sont les données que vous avez maintenant sur votre image. Par exemple, là, vous avez les plants de tomates et les tomates en elles-mêmes sur l'image.
Okay, all right. So that's main things. I also have a piece of code that is in the repository that can help you with tuning your thresholding function. Let me show that to you. It is here called color thresh. And how you use it, you give it an image name. So this would be images.
Donc, vous avez la possibilité de regarder dans votre répertoire GitHub, dans le répertoire GitHub qui a été fourni. Vous aurez la possibilité de voir là-bas des fonctions qui vous permettra de réarranger votre code de manière générale en ce qui concerne le color space et thresholding image.
All right, so I just wanted to bring this up so you can see it better over here. So image, and then we got images, and let's say image 0.jpg. And this shows the original image, this shows the thresholded image, and has a nice controls here that we can use to play around with all the different channels. Let's see, channel 0, channel 1, channel 2. All right. So we can play with the 3 channels. And we can use this to choose the right, low and high, or minimum or maximum that works best for our image. And keep moving things around. So it's very helpful tool, actually, you can use. You see that?
Donc, cette fonction contrôle, en fait, vous permet de naviguer un peu plus facilement sur votre choix de range pour les colors.
So you can keep moving different things to see where you get a good good setting. All right, so you can use this essentially. It's in the repository, so you feel free to use it. It's very, I've found it to be very helpful, very useful in general, not only for this project, but even other projects as well. You can also change the color space to HSV or lab or all the ones that I showed you before. Change it. And then you can check first of all, you can check which color space is the best for identifying these things.
Donc, vous aurez accès à cette option contrôle dans le répertoire GitHub. Ça vous permettra en fait de facilement trouver les ranges de couleurs dont vous avez besoin pour faire la suite de votre code.
All right, so yeah, you can spend a lot of time playing with it. So that's pretty much it. This is a very helpful tool. All right, very good. So again, how you run it, I also have it in the repository, but how you run it is to use color threshold. Let me show you to you the repository. All right, so any questions? People have any questions? We are about at the end. Hopefully this has been helpful to explain some ways of approaching task 2.
Est-ce que vous avez des questions par rapport au workshop d'aujourd'hui?
All right, so you can use, yeah, I think this is it. You can run this. You can run this and you can get what I just showed you. The last thing I want to show you is an example way of trying to solve task 2. Once you can do a threshold and do a mask, then you can start to think about how you count the number of things there. Okay, so that is the thing I want you to think about. How can I now, once I have isolated the fruits, how can I count them? That's the main task for task 2, right? To do some counting. So I'm using a particular method here, but I did not introduce this here because I want you to think, and you can use this opportunity to learn more about OpenCV and check what are all the available functions in OpenCV that you can use for some of this.
Donc là, par exemple, vous avez un exemple de solution pour la tâche numéro 2. Ça vous permettra cette fois-ci, par exemple, de compter le nombre de tomates qu'il y a sur le plan de tomates. Donc, ouais.
All right. Hopefully this has all been good. People were quite quiet today. Any questions or people have? It's about time for us to wrap up today. I'm happy to take 1 or 2 questions if anybody has any general questions. Thank you, Samuel, for putting this resource on object-oriented programming. Let me see what it looks like. Yeah, this looks nice. Yeah, object-oriented programming is a very helpful, powerful tool for programming in general. So it'll be good to learn how to use it and some, but I'll also see if I can find additional resources, and I'll put it in the I'll put it, but this looks very good actually. Thank you, Samuel.
Ceux qui ont toujours des difficultés sur OOP, la programmation d'objets orientés, vous pouvez avoir accès au lien que Samuel a mis dans le chat, ou patienter, du fait que Kenny trouve encore un peu plus d'informations sur comment utiliser le OOP sur Python pour vous, et il vous enverra par email.
Okay. All right, so it looks like we don't have any questions. All right, so thank you everyone. I will upload the recording to our regular place on the website, and I'll let us know once it's there. I'm going to put it up here with the slides. Also, you know that this is already available. Once we are done, I'm going to upload the code that we wrote together. So this is empty right now, but it will have the code that we wrote together, so you can see it.
Donc, le code qui est aujourd'hui, vous aurez accès à ce code dans le lien, et ensuite, vous aurez aussi accès au record et à l'enregistrement d'aujourd'hui sur le lien de PARC 2024.
All right, so if there are no other questions or comments, thank you all very much. I'm going to stop recording.